Hi, this is the third lecture of the logic and the set theory. We will introduce you to the propositional logic, and here we will include, of course, the truth table and so on. So we will first learn about the argument forms and logical operators and formalization or well-formed formula, how to form a good sentence in logic, and the truth table. Of course, I remind you the course homepage and the Moodle page or KLMS page. So there are some other references you can use. One of these is by Jeffrey, and these books, if you can find these, be helpful. And also Plato again at Stanford has other resources. I list out the OCW course in MIT. I don't know if it will be helpful to you or not. So first we begin with argument forms. So let's say PQR represents some sentences, not necessarily atomic sentences. Either today is Monday or Tuesday. P or Q. You can write this. Today is Monday or today is Tuesday. If you have bad grades at KAIST, then you can get kicked out. Okay, so if P, then Q. If P and Q, then R. It is not the case R. It is not the case P and Q. Okay, so these are all argument forms, and we will learn how to formalize these. So there will be things called logical operators. So first one is the negation operator. So you write in this way, or you can use a tilde or this symbol here, or you can use a wedge or this ampersand for and, or you can use this V here for or. So if and then this is symbolized by an arrow. If and only if this is symbolized by arrow left and right arrow. So you can see some PM notations from here, and there are some articles on logical connectives. And sometimes this mark is used to mark the conclusion, but it's not necessarily inside the logical operators. You can say maybe it's not. So these operators, just like any other binary operators or unary operators, they have some precedence. So order of precedence determines which connective is the main connective when interpreting the non-atomic formula. So as a way of reducing the number of necessary parentheses, one may introduce the precedence rule. Of course, it's not always necessary to have the precedence rule, but it will simplify our writing. So operator precedence is negation is the first, and is the second, or is the third, and arrow is the fourth. Left right arrow is the last here. So for example, if you have a P or Q and not R, S imply S is short for, so negation is the first, and is the second, and or is the third, and then this is the last. Okay. So that's the precedence. You can shorten the writing because you can reduce the number of parentheses here. Of course, parentheses is a part of the logical connectives. You can kind of think of it that way. So formalization, you can formalize any sentence by dividing into atomic parts. Okay? So it's not both raining and snowing. If you say R represent it is snowing, S represent it is R represent it's raining, S represent it's snowing, then this will represent this sentence. It's not raining or it is not snowing. You can write it in this way. Okay, so every English sentence can be made into an atomic pieces, and written as a in logical form. Okay, so maybe for a given sentence, you might have two different way to write it, but the meaning has to be the same, or the people who write this sentence has to have in mind these logical form. Otherwise, they are not knowing what they are talking about actually. Right? Okay. So this is a kind of a Russellian idea. Okay. So well-formed formula or WFF. So if you see something like this, then this is nonsense because this is what you call unary operator, but you have two connective, so it's written as binary. So this is nonsense. So it is defined. We can define any well-formed formula inductively. So actually, this negation is called the unary, and these are always called binary operators. So we can define inductively any sentence letter is WFF. So any letters like P or Q or R is a WFF. So if you have a WFF, you can do the negation. Okay, that's WFF. If phi and psi are WFF, so is the and or implies or left right arrow. These are if are or going to be well-formed formula. So sub well-formed formula is well-formed formula inside the well-formed formula. Okay. So sometimes some parts will not be a sub well-formed formula. As long as atomic sentence letters are well defined, there is no ambiguity in the meaning of WFF once you build in this way. So this is an inductive way to build well-formed formula. So if you are a very logical person, then you will have to write every sentence with a well-formed formula in mind. Okay. So let's go to some example. Either there is no Starbucks in Daejeon, or I do not buy coffee beans. Okay. So this means that so S means that there is a Starbucks in Daejeon, and B means I buy coffee beans. Okay. So this means that there is no Starbucks, or I do not buy coffee beans. Okay. So if I buy coffee beans, then there is no Starbucks in Daejeon. So if I buy coffee beans, then there is no Starbucks in Daejeon. So another example is if there are no God, then no movement is possible, but there are movements, hence God exists. So if there is no God, there will be no movement. So G means there is God, M means there is movement. Okay, so since there is movement, there is God. Okay. So there are some other exercises. Either it is raining or it is both snowing and raining. Okay, R or R and S. Either it is both raining and snowing, or it is snowing but not raining. Okay, so this will represent this sentence here. So this is the first part of the lecture. We will continue with the second part.